all set.
Thank you. Ready?
All set.
Thanks. Well, good afternoon. It's our pleasure to have Professor Jean Camp today as the speaker of our seminar. Professor Jean Camp's research interest falls in the interaction of social, economic, and technical trust. And for the people who have done research in privacy and trust, Jean Camp is a very well-known name and really does not need much of introduction. Professor Jean Camp is currently at Indiana University School of Informatics, and prior to that has been working in this area of research at Sandia National Laboratories and Kennedy School of Government at Harvard. Professor Camp?
Thank you. All right, I want to talk today about a different way to think about security and designing security. The core argument I'll make during this entire presentation is that you need to design a security system that functions within the social and economic environment in which it is implemented. In particular, I'm going to look at how we embed trust using social context. The core of this system is not that we will cryptographically verify that phishers, those who implement phishing attacks, are bad parties. The point is to enhance individuals' ability to make trust decisions. All right? So I'm going to talk about the definition. Do I have to? I hate standing back there. I'm going to talk about a very different way to design the system, a way in which you start with the human being who uses the system and the task they're trying to fulfill, right? So we had this joke at Sandia National Labs when I was in the security group. They said, oh, you need to come over now and add the security to it. And we said, oh, just run it slow. We never really did that. But that's the idea, that security is something that gets in people's way and people want to avoid it, right? The proposed system, we look at the interfaces. I talk a little bit about the simulation. If I have time, I'll talk about the protocols. But before you'll see how the interfaces lead to the protocols. And I will leave this presentation. You'll have the entire presentation with the protocol slides if you're interested in obtaining it. So it's on this computer. So what's our core problem statement? This is our core problem. We need to create reliable economic signals to inform individual decisions. I will assert that no human being has ever been so drunken that they walked into an internet kiosk in Nigeria and thought they were at the bank. All right? I'm just going to push that assertion to you. We have thousands of people do that every day on the internet. People are not making informed trust decisions. All right? So let's talk about designing for trust. Let's start with human trust behaviors. It's very different. Instead of starting to discuss your work factors. Trust, what is it? Fundamentally, trust is about simplification. Trust enables activities to happen that could not happen otherwise. So that's why trust but verify is kind of a joke, because if you can verify, you don't have to trust. There are three things that make a decision trust. One, the action cannot happen without it. Two, there's a time lag. Like, okay, I'm not really trusting him not to poke me in the eye with a pen for two reasons. One, I have glasses, so I'm protected. Two, he would do it immediately and I know it was done. You see, there's not a time lag. Whereas if I gave you a message or a pen and I said, promise me you're going to poke somebody in the eye with that pen later, there'd be a time lag and it would be trust. And then the third thing is you cannot necessarily know who is the responsible party if it happens later. The thing about trust is it encompasses what we think of as discrete technical problems. We solve problems like confidentiality in transmission, which is an element of trust from the end user. And it embeds discrete policy problems. If they have great data security in terms of their network, and whenever I call the business center helpline, I get, anatomical suggestions, I don't think that that's trust. Let's think about human trust and computer trust. Human trust. There are a lot of experiments about how people extend trust. Almost every cryptographic system is built with the opposite assumption of trust behaviors, right? Because computers aren't people. And at the philosophical level, trust is a need. So you need to accept that individuals will begin with being trustworthy. And that it's a tool for simplification. You want people to trust, you make it easy for them. You want them not to trust, you make it easy for them. And finally, you can look at trust as game-theoretic. There's been a lot of research on how human beings behave with respect to trust. One of them says, human beings don't differentiate between machines. Computers are very good at differentiating and not very good at categorizing, right? What's a table? You and I, if we walked in and there were a table and it was here, it was this wide and it only had one leg, would not be confused and say, oh, one leg, it's a stool, right? The computer would be confused. So we like to lump, and computers like to differentiate. Humans also become more trusting of the network. Every study of human trust has shown that people, the more they use the computer, generally instead of becoming more savvy and slick, they generalize. They say, well, I've used this computer a lot and it hasn't exploded, so I'll go ahead and trust it. Is there a major road next to this university by any chance? 65. Yeah, okay. So when I worked at Harvard, there's this incredibly busy road, Massachusetts Avenue, that goes right through Harvard Square. And the students are as smart as students anywhere, and they would walk across that road back and forth every day. And every semester, some student would get hit because they didn't look. Why didn't they look? Because they'd walked across that road successfully every day. We do the same thing with computers. We're very bad at risk. And we default to trust. And like I said, in the slide, there are reams of validation of how people default to trust. And that is what so much fraud is about. If somebody comes up to you and says, I lost my wallet, the first thing you think is, oh, they lost their wallet, right? Not, oh, I wonder if they're armed, because they're obviously a fraudster. Okay, a lot of computer scientists would be more likely to think, I wonder if they're armed. So one of the things we need to think about when we design for trust is, what are we really trying to do? Are we trying to get people to trust the network? Are we trying to get people to mistrust wisely? It's a different kind of argument, and that's where the signaling part comes in. You want people to be able to distinguish the good resources and the bad ones. People are too trusting. They learn to trust, and then they trust even more, right? And we need to add an element of mistrust and differentiation, another human behavior. The tendency to differentiate between remote machines decreases with computer experience. Not with computer education, right? Experience is different from education. You could have played 4,000 hours on World of Warcraft and still believe that when you hit delete, your file goes into Never Never Land.